For step 6, we will find the ratio of mean squares. The ratio of mean squares, it gives us an idea of how much variation is due to that between groups compared to that within groups. Sometimes this ratio is called an F ratio, or sometimes it's called an F statistic. This ratio, which is sometimes labeled F, is simply the mean squares between divided by the mean squares within. To put it another way, conceptually it's the average variability across groups divided by the average variability within groups. In our case, we have an F ratio of 64 divided by 1.67, or about 38.23. Now I want you to think for a second what it means to have more variability, a higher mean square between compared to a mean square within. When you have a high mean square between, when the groups are really different from each other, that suggests your data really cluster into distinct groups. In contrast, if the mean square within is much larger than the mean square between, that suggests that these groups really aren't all that different. Most of the variability in your data set is due to that across or between individuals, not between groups. So the important point here is that this ratio gives us an idea of whether our variability is in terms of differences between individuals or differences between groups. Or to put another way, is the variability more within groups or is it more between groups? So let's go over this in just a second in terms of interpreting and understanding the F ratio. When we calculate one-way ANOVA and when we conduct this kind of analysis, our null hypothesis, it's that all these population means are equal for these 3 or more different groups. The alternative is simply that these means are not all equal. Under the null hypothesis that all these groups have equal population means, the mean squares between and the mean squares within, they can be viewed as 2 estimates of the population variance, which we call sigma squared. If the null is true, right, if all these different groups have means that are equal, then the mean squares between and the mean squares within shouldn't be that different. And thus the F ratio should be really close to 1. Because if the mean squares between and mean squares within are not all that different, right, then we can say that there isn't much clustering going on. Think of it this way. If the mean squares between is really much larger than the mean squares within, that suggests that most of the differences are across groups, that these groups, all these individuals kind of cluster around these groups. But if the mean squares between and the mean squares within, if that ratio between the two is close to 1, that suggests that they really are part of the same population overall. So let's put all of this together in just a moment.